This is my Milestone 2 presentation for the thermocouple experiment in ME341. So, the progress that I've done so far, I finished all the Milestone 2, so steps 7 through 9. So I finished all the initial testing. I found the necessary frequency and time requirements that we found from steps 7 through 9. I'm a bit concerned about the accuracy of the data, specifically from 8 and 9. Step 7 was a lot easier to find the points needed on our graphs, but 8 and 9 were a little more subjective. Remaining work, might want to test some data more, but I definitely need to talk to either professor or TA and find out how accurate my own data is. So, photo of my setup, very similar to the last one. I have my cold bath right here, and then I have my actual Arduino setup here, all hooked up to my laptop. So from step 8, I ended up finding that the time requirement was 2 seconds. 2 seconds was just enough. That I found ample time before, during, and after submersion without having too many values. For step 9, I found that the time was 5 seconds. 5 seconds, not much changed after 5 seconds. And that at a frequency of 27 hertz, I was able to see that change in temperature pretty well as compared to the 10 hertz. For the thermocouple experiment, this was our step 7, so this was the amount of time it took for the thermocouple to return to room temperature after coming at the ice bath. So this right here, time in seconds, temperature, thermocouple value. We see it starts off very low down here towards the 254 range, and we do hit values close to what we'd say is normal, 269. That's around 395 seconds. However, you can see here it really starts to, this is where it becomes truly level, and after this point it stays, except for a few outliers, at around the 269 to 272 range, which is our norm. So I called at 450 seconds. This is the point where we can say that it is returned to room temperature. So then, go to step 8. Now step 8, we're showing our thermocouple value here. This is our mock trial. This was the room temperature, and this was my trial at t equals 2 seconds. All our times are in microseconds this time. So just looking at our mock trial here, we see that we have a pretty good source of data here for before the submersion. During submersion is pretty alright, and then we have lots and lots of extra time afterwards. So I shortened it down to 2 seconds. And we can see here we still have great a deal of time beforehand, same during, but then we still have quite a bit after, but it's a much easier data set to work with. And we want to make sure that even if we can't see where it levels out, that we include it. So in step 9, last step, wanted to find ample frequency and time such that we'd be able to observe coming out to steady state. So after a few trials, which were not labeled, actually this one was 20 hertz, we discovered that at its frequency of 27 hertz, this particular dip stopped being a straight line, and it showed an actual shape, a bit of an arc. So this helps us realize that this is actually a much more detailed description of the temperature change. And 5 seconds was set because in the grand equilibrium, it's going to be somewhere between 5 seconds and, say, here, but to the human eye it might not be so easy to see, so I chose 5 seconds, which is still not too many data points. And with 270 or with 27 hertz, it's still only 150 or so data points. So that's how we're here to answer the questions. Why should we use a large insulated cup for step 6C? 6C is where we set up our experiment. So this is because we don't want any contact with the ice with the thermocouple. Ice is going to be less than 32 degrees Fahrenheit because it's frozen. So if we contact the actual ice, the thermocouple will be reading something that is less than 32, and we want to be as close to 32 as possible, which is going to be the temperature of the water. We also want to look at how many minutes does the sensing end take to return to room temperature, and this was explained in step 7. This is 7.5 minutes, which is 450 seconds, and that is because based off of our graph, that's a point where everywhere after that is within the normal range. There are a few outliers, but compared to before, where the outliers were the normal range, now the normal range is consistent throughout. So at 7.5 minutes, we can say it's returned to room temperature.